Hello, welcome back to the episode 46 of Learning Kotlin Life. And yeah, today we're going to read some new things. Probably Coroutine, I guess, because I think I'm going to read Coroutine and use Coroutine in some really near future, and Coroutine sounds promising, and that's definitely one of the things that we would like to learn. Improve from Java to Kotlin, of course. So let's do it then. Can you hear me now? Yeah, I think so. So basically, sorry, I'm still coughing. Coroutines for asynchronous programming and more. Synchronous or non-blocking programming is a new reality. Whether we're creating server-side, desktop, or mobile applications, yeah, these are just where Kotlin is useful for. It's important that we provide an experience that is not only fluid from the user's perspective, but scalable when needed. There are many approaches to this problem. In Kotlin, we take a very flexible one by providing coroutine support. Why is it pointing there to there? At the language level, and delegating most of the functionality to libraries, much in line with Kotlin's philosophy. Yes. As a bonus, coroutine not only open the doors of asynchronous programming, but also provide a wealth of other possibilities such as concurrency, actors. This is something new to me, etc. So how to start? This is the Kotlin syntax. No. So probably the coroutine guide or coroutine basics. Coroutine guide, and yeah, it's just an index or Kotlin as a language provides only minimal level APIs in its singular library to enable various other libraries. So many other languages or libraries uses async and await, but they are not part of. No, they are not part of this library. So this is just comparing async and await based futures and promise and to Kotlin suspending function, and this is the Kotlin tutorial. What else do you expect? It is definitely going to tell you that Kotlin is better. So Kotlin in X.coroutine is a rich library by JetBrains, and it contains a number of high-level coroutines enabled primitive, including launch, async, and others. So this is a guide for Kotlin X.coroutines. And in order to use coroutines as well as follow the examples in the guide, you need to add the dependency on Kotlin X coroutine core. Okay, we're not going to go into it, but let's move on to coroutine basics. Your first coroutine. Lovely. So this section covers basic coroutine concepts, running the forwarding code. There's a global scope that launch and a delay in it, and hello and thread.sleep. Huh? What's the result? Come on. Hello world. Hey, wait. Oh, so this is just illustrating that hello prints earlier than world, and the reason behind it is we probably started another coroutine. Yeah, launch new coroutine in background and continue. So this is on blocking, and then simply a print line is triggered. So to to prevent this whole block from finishing, there's a block main thread for 2 seconds to keep JVM alive, and during this 2 second, the coroutine do something, and it blocks for um 1 minute, actually 1 second, but not on the main function, but in the coroutine itself. So later world is print, and that's the whole thing. So essentially, coroutines are lightweight threads. So this global scope that launch is probably takes a runnable and runs a coroutine. Let's see if we're correct. It takes a context. Mm-hmm. Mm-hmm. So these two are optional. So the only thing we will need is a unit to coroutine scope to units, the span function, and I don't think it is provided here, actually. Huh. Huh. Interesting. So yeah, let's move on then. So with a new thread, blah blah, and delay and thread that sleeve, you can do the same thing. So span functions are only allowed to be called from a coroutine or another. Oh, so there it is. Delay is the suspend function. This is the function. Coroutine is the suspend function. So delay is the suspend function, but how does it make something that is following it a suspend function as well? So my guess is there are some secrets in between these two brackets. That's my guess. Just my wild guess. So this delay itself, oh, it's actually coroutine delay rather than Java delay, so that's why. And yes, it is a suspend function which returns a unit source. Which returns a unit. What does this source here mean? Oh, that's just the coroutine source. Nah. Okay. So this actually returns a job. Okay. So bridging block and non-blocking words. Yeah, this is exactly what I want. There's a non-blocking delay, and is there a sleep? No, I don't think there's. Oh, here it is. There's a thread of sleep. There's a delay and a thread that sleep. Run blocking coroutine builder. So there's the new thing is there's a coroutine builder, which is called run blocking, and the run blocking. Huh. I don't I'm not sure it's if there's okay. So no, there's no actual difference between these two examples. The result is the same, but this code uses only non-blocking delay. Uh-huh. The main thread that involves round blocking blocks until the coroutine inside round blocking completes. Okay. So this is a comparison between global scope.launch, which creates another coroutine, um, and that coroutine is non-blocking, or just like creating a worker thread in Java, although there is no thread created in this syntax, and a round blocking delay. So that's basically the same. Yeah. So the example can also be returned in a more idiomatic way, using round blocking to wrap the execution of the main function. What? What? Why? Round blocking, it's always unit, I guess. Or, yeah, it has generics for some reason, so. But anyway, global scope.launch. So this time, this main is itself is a big blocking coroutine, and because it is a coroutine, so it can run delay here directly. I believe that thread.sleep will work here as well, but anyway. It works as an adapter that is used to start the top level main coroutine. We explicitly specified its unit because a well-formed main function in Kotlin has to return unit. Oh, that's why, okay. This is also a way to write unit tests for suspending functions. Ah, okay. To make everything blocking. That's the purpose of this. Waiting for sorry. Waiting for a job, delaying for a time while another coroutine is working is not a good approach. Let's explicitly wait in a non-blocking way until the background job that we have launched. Oh, this join looks exactly like Java thread. So yeah, it works like Java thread as well. We take a reference of the job and job.join, join who? Wait until child coroutine completes. Oh, this thread, this main thread will wait for this job until it can be joined. I'm not sure if that's idiomatically correct, but that's the idea. So this will probably hello, and later this line will not execute until world is printed and it exists. Now the result is still the same, but the code of the main coroutine is not tied to the duration of the background job in any way. Much better, huh? Okay, it's just talking about how it abstracts everything in a job. Structured concurrency. So there is still something to be desired for practical usage of coroutines. When we use global scope.launch, we create a top level coroutine. Even though it is lightweight, it still consumes some memory, of course, resources while it runs. If we forget to keep a reference to the newly launched coroutine, it still runs. Yeah, of course. So, actually, yeah, it makes some sense. What if the code in a coroutine hangs? For example, we erroneously delayed for too long. What if we launched too many coroutines and ran out of memory? Having to manually keep a reference to all the launch coroutines and join them is error prone. So that means don't join them. Don't simply join them. There is a better solution. We can use structured concurrency in our code. Instead of launching coroutines in a global scope, yeah, I have not talked about what global scope is yet, but it's probably a largest pool global variable, just like we usually do with threads. Threads are always global. Yeah, maybe. We can launch coroutines in the specific scope of the operation we are performing. So this is talking about that we can tie the life cycle of a coroutine to the running a life cycle of another object. In our example, we have main function that is turned into a coroutine using run blocking coroutine builder. Every coroutine builder, including run blocking, add an instance of coroutine scope. So that's probably a point. There's a coroutine scope class. To its code block, we can launch coroutines in this scope without having to join them explicitly. Wait. We can launch coroutines in this scope without having to join them explicitly because an outer coroutine does not complete until all the coroutines launched in its scope completes. Thus, we can make our example simpler. So we have a main and it run blocking, and we use run blocking to build a coroutine. And in a coroutine, we launch again. What? Why do you launch again? Launch new coroutine in the scope of run blocking. Yeah. And in that, it delay and print loan. And in the first run blocking, it prints hello. So this is still a hello world. Yeah. Scope builder. In addition to the coroutine scope provided by different builders, it is possible to declare your own scope using coroutines builder. So, so this run blocking probably build a okay. So this is for blocking codes. We create some blocking code here and wrap it with these run blocking, and that would be a coroutine scope. Is it? And with that scope, we can launch another coroutine directly. But with launch, we're running a non-blocking coroutine. So here we're going to talk about these scope builders. In addition to the coroutine scope provided by different builders, it is possible to declare your own scope. Oh, okay, lovely. So this coroutine scope, create a new coroutine scope. It creates new coroutine scope and does not complete until all launch children complete. The main difference between run blocking and coroutine scope is that, coroutine scope is another, that's another builder. There are so many scope builder, and coroutine scope is yet another scope. Okay. So the main difference between run blocking and coroutine scope is that the latter does not block the current thread while waiting for all children to complete. It still waits for all children to complete, but it's non-blocking. But run blocking is blocking and blocks your whichever thread you were on. And for launch, it probably doesn't wait for um, all children to complete. Extract function refactor. Let's extract a block of code inside launch in a separate function. When you perform extract function refactoring on this code, you'll get a new function with suspend modifier. That's the do world, this part. Where is it? Where was it? Oh, let's first take a look at this example. So there's a big run blocking scope. Everything inside this is blocking. And we launch delay. So because this is launch delay, it will delay for 200 milliseconds, and tests for run blocking will be printed after that delay. And here again we have a coroutine scope which waits for everything, so we don't really need that delay to after this coroutine scope, I mean something here, because we know that it is going to be waiting for all of its child. So basically, print loan coroutine scope is over but it's definitely the first one. It's actually blocking. No, everything is blocking here. So yeah, this basically is the first one. And then there's a delay. After delay 200 milliseconds, test from run blocking will run. And another thing that might happen is, well, because launch is not blocking, but delay is it? No, they are all non-blocking. Wait. They are all non-blocking, but everything in between it will be done sequentially. Yeah, because this coroutine scope itself is non-blocking, so we will see this coroutine scope is over first. And then after 100 milliseconds, print loan test from coroutine scope will show as well. Then, because launch is non-blocking as well, print loan test from run blocking. That's the next one. And launch delay 500 milliseconds. Launch is not blocking as well, so yeah, that's just 1, 2, 3, 4. Oh, actually no. Oh, so because run blocking waits for all child coroutines to complete before completing itself. Really? So it first run the launch. And in that launch it is non-blocking, so there's a delay. And so that basically means, oh, I'm confused. Wait. Maybe test from run blocking first? No. Oh my god. Why is this happening? Wait. So task from coroutine scope. So everything here launches. It is run blocking. So probably every line blocks. Then that makes no sense, because if every line blocks, oh, but that's a launch. So this line blocks and this coroutine completes. But no. this complete. It's not complete after some like. Oh, this is so annoying. So wait. We launch it. And it. When does it complete? It complete after 0.2 0.2 second, but that basically means, well, I still don't quite get why this is run at last. Why Coroutine scope is over. This is so weird. So basically it probably has some so what if, yeah, so this is my question, but I can't edit it here. Is there anything like, huh? Oh, that's a show answer. Huh? Oh, 1.1? I don't think we have Kotlin with it then. I mean, we don't have Coroutine with. Yeah, we don't have Coroutine. No, I need a compiler. Is there any way that I can just don't use these examples? No, I don't want this introduction. I don't want these examples. I want just whatever way I can. Need to log in. So it's by JetBrains. Looks good to me. Finally, test from Coroutine scope. What if we have it this here? let's call it 1, 2, and 3. Why? This doesn't make any sense to me. Why? Wait. Um. Is it because of this coroutine scope? Seems so. So it's not because of this round blocking. This coroutine scope. Oh yeah, that's also what it was mentioning here. So there's a coroutine scope, and it creates new coroutine scope and does not complete until all launch children complete. So that's basically the thing. We launch, and so that means it's still kind of blocking. It creates new coroutine scope and does not complete until all launch children complete. The main difference between the latter does not block the current thread while waiting for all children to complete. Really? I kind of feel like it is still blocked. Is it not? 1 and then 2, 1 and this is launched and completes, and 2 and this is launched and it is launched and delays for 100 milliseconds, and this is printed, test from coroutine scope, and then this completes, and after another 100 milliseconds, test from run blocking completes, and that is finally when this is launched after 300 more milliseconds. Test from nested launch is complete, and finally this whole coroutine scope completes and we can print 3. But that's so weird. What's the difference between? Is it only a spiritual difference? Conceptual difference? Because I kind of feel like this run blocking will be the same here. The result, the printing result will be the same. 1, 2, and blah blah blah, and 3. Oh, actually no. This now ends last? Huh? Huh? Why? Why? Wait. Huh? Test from run blocking. What? Why? I'm so confused. Anyone in the chat that can help me? Nope. No one in the chat, so I'm really confused now. 1, 2. Why is this launch now blocked? Oh, and furthermore, 1, 2, 3. Is something missing now? 1, 2, 3. Oh, it was replaced by this 3. So, wait. Is it just some randomness? 1, 2, blah blah blah, 3, and yeah, it's always 1, 2, blah blah blah, 3. But if this, oh, that's coroutine scope. And for run blocking, it's 1, 2, blah blah, 3 blah. So this one is blocked. And this one is here. I don't get why. I don't get why this is blocked. Because this is another coroutine, right? So is this launch? I mean, probably this launch. Oh, this launch is blocking. And this launch is blocking as well, so that makes no sense to me. Okay, this is just too hard for me. We really should stop here because I'm running out of time, but kind of feel like oh, that's, come on, let's try this for some other resource now. Not until everything inside this completes, the main thread will complete. And if we have another run blocking, so that basically blocks the main thread as well, because we only have one main thread. So print 1, print 2, but why? Why here? Why something on another, in another coroutine scope is, let's see, let's take a look at launch maybe. New coroutine without blocking current thread and returns reference to coroutine as a job. Coroutine is cancelled, then the resulting job is cancelled. So let's first understand if there are multiple launches in a probably still flux. Am I disconnected? Do you guys still hear me? Yep, I'm still connected. But the server seems to be broken. No main method found in project. What else can this be if there is no main method? Or is it simply like oh, you need a coroutine. Come on, give me the result. Can't get program output. Oh, I think I need a try catch or something like that. One, two, test from run plug. Oh, I need 1 and 2. So yeah, it is not blocking. It is not blocking for launch like this. So why is this blocking then? Yeah, this shouldn't be blocking by another launch. Or maybe something within a round blocking is weird within a round blocking. Yeah, why test from round blocking ends last? Hmm. 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 Or another way to look at this is everything are just simply for unknown reason. Oh, so because this is round blocking. So these two are okay, that makes sense. But what about this delay? Yeah, should have known that. What about this? It's still the last one to complete? Really? kind of feel like this block is still very weird. Very hard to. Right, I'm giving up. So anyway, we know that coroutine scope are blocking, not blocking, but waits for every children to be launched, but run blocking is blocking. Well, this was my first question, but what I'm wondering is not this. So, but I still believe that normally no one is putting a run blocking inside the run blocking. So maybe that's not some case that we would like to look into. But that's definitely weird, and I would. Yeah. So probably it's just unwise to use run blocking inside run blocking. It makes everything blocking. No. No. So yeah, that's super weird. I will ask my colleague about who happens to be a coroutine master and nah, yeah. Yeah, I don't think I'm strong enough to understand what's happening inside here. So that's all for today. See you next time.